Hi people, we're doing well. As promised, a little bit tardy, but as promised, I'm going to go ahead and show you the proof for the chain rule. Not necessary for everybody, but in case you're curious, I like to show you where all these things come from. Now, if we are dealing with a composite function, let's call it h of x, and let's define h of x as f of g of x. Then by limit definition, h prime of x is the limit as h approaches 0 of f of g of x plus h minus f of g of x, all of that over h. Now, unlike the combination functions, this is going to be a little more difficult. And so some of it may not make perfect sense, but just I'm going to try and go slow and deliberately so that things are clear. Now, the first thing we need to notice that if g of x is differentiable, and in order for this, h prime of x to exist, then it has to be, then the limit as h approaches 0 of g of x plus h minus g of x over h, so this is the usual thing, minus g prime of x is equal to 0. And so if that would normally be the derivative, but basically this is charting how as h goes to 0, this expression and this expression get closer and closer and closer, and basically the difference between them goes to 0. Because this basically becomes g prime as h approaches 0. So basically as this approaches g prime, then the difference between it and g prime approaches 0. Now, that shouldn't be too big of a deal, but let's let v equal g of x plus h minus g of x, all of that over h, minus g prime of x. So what's here in this brackets, we're going to let that equal v, okay? And so now we can shorthand it as the limit as h approaches 0 of v is equal to 0. So, okay, so first step done. Let's talk about f. If f of x is differentiable, and for h prime it must be, and in order for h prime to exist, then it must be, then the limit as k approaches 0, and we're using k instead of h because remember that the output for g winds up being the input for f, so we're trying to distinguish between the quantities of x and y and h, and we're calling the replacement of it, but it serves the same purpose for f. The replacement for h is k on this one, and so f of y plus k minus f of y, all of that over k, minus f prime of y. Now, basically this is saying the same thing for f that this is saying about g. This quantity right here, as k goes to 0, this quantity becomes f prime. So basically, as k goes to 0, the difference between this quantity and f prime goes to 0. Okay, well, we're going to do something similar by basically creating another variable to be shorthand. And so let's let w equal that quantity that we see inside the brackets. Okay, so now we know that the limit as k approaches 0 of w is equal to 0. Okay. Now, we're actually now going to back up and use these two in a different form to sort of rewrite some quantities, okay? And we're going to use it in sort of a substitution kind of way. So let's rewrite both of our equations, and the first one becomes rewritten. So basically, we're going to rewrite our V and W equations that we just created. And the first one is going to be g of x plus h. We're going to solve for it, just, kind of like a z problem. And what happens is we get that when we solve for g of x plus h. And we're going to do something similar for f. F of y plus k is equal to f of y plus f prime of y plus w times k. Now, we need to use function notation to do a little bit of basically rewriting and re-representing. So we're going to use function notation. And we notice that f of g of x plus h is going to be f of g of x plus g prime of x plus v times h, right? Because all we're doing, instead of g of x plus h, we're drawing this whole big long thing, okay? So basically we're just replacing one representation for the other. Okay, now we're going to do, now what we're going to do is basically what happens, we have f, basically this winds up being f of g of x plus g prime of x plus v times h. Okay. Now, what happens here is because we know the y, f of y plus k, we're going to actually, basically this winds up being my y, okay? This winds up being my y, and this winds up being my k. So remember, f of y plus k, okay? And then we're basically going to take these two quantities as y and k and basically create f of g of x plus f prime of g of x plus w. And here's the tricky part. This k right here, we're going to represent as this, okay? So that k becomes, basically, it becomes g prime of x plus v times h. So if this is the y and this is the k, then this right here is my f of y. This right here is my f prime of y plus w, and this right here is my k value. Now this is probably the hardest sort of leap to make right here, but basically the hardest part is this part right here to get your mind around. And if you want to discuss it a little bit more, then we can of course discuss it another time, and I can sort of iron it out. But if so far as you believe me, we'll just keep going. So now we can rewrite again, yes. And so we have f of g of x plus h minus f of g of x over h. Now remember, we're going to plot this down into the limit in just a second, but for right now, what we're going to do is we're going to try and rewrite it and see kind of if we can, basically it's a matter of rewriting so you can play with the quantities and reveal something new. What we have here is f of g of x, right? Because this whole thing is the g of x plus h, right? Because if g of x plus h equals this, and this equals that, then by the transitive, this equals that. And so we're going to rewrite this quantity, okay, plus, f prime of g of x plus w, and g prime of x plus v h. Now, what you may have already recognized is the fact that this rewriting of f of g of x plus h provides you with an f of g of x, a positive f of g of x, which then again down here at the other end is being subtracted. So what happens here is these two cancel out because they're additive inverses. And then these two cancel out. And what happens here is I'm left with f prime of g of x plus this w quantity times g prime of x plus this v quantity. Now, we're going to go ahead and place this back in the limit, but we need to remember that both v and w go to 0 as h goes to 0. So if we have h prime of x is equal to the limit as h approaches 0, this is equivalent to this. So we're just going to take the limit of this rewritten version. And as h goes to 0, both w and v go to 0. And so we're just left with f prime of g of x times g prime of x, and boom. That is the proof of the chain rule. Now, you may not have gotten all of that, but I hope that you were able to follow along to some extent. A lot of it is just creative rewriting such that you can sort of represent the information in a different way. Things cancel out, and you're left with what we've learned in terms of the chain rule. Watch it again, and if you have any questions, we can chat about it outside of class or something like that. But I hope you're doing well on your homework tonight. If you have any questions, please do email me. Bye.